Welcome to the classroom. Today we're talking about coastlines. Now, there are three main types of coastlines. We have a sediment-dominated input coastline. That's where we form a lot of deltas. That's where you have a river flowing out off the continent into a lake or the ocean or a sea. You have a river inflow. If it carries a lot of sediment, it's going to create a landform called a delta. That's a buildup of sediment. Now, if you don't have a lot of input from a river and you're in a marine environment with saline water and it's a nice warm environment, you could have an abundance of fossils, okay? The organisms building their shells and their homes like a coral reef out of calcium that they get from the water. When they die, their shells form limestone in these marine environments. You can also get high saline environments in the coast where you have some protected areas and you get a lot of salt water and salt evaporite minerals forming as the tide fluctuates. And the final coastal environment is your typical coastline where we have a lot of waves coming across the lake impacting the shoreline. That's our three main coastal environments. We have a deltaic environment dominated by sediment input from the continent. We have a wave-dominated environment. It can be a marine environment where we have evaporites or we have organism-dominated biochemical rocks forming. Now, we also construct landforms to take advantage of how they interact with the flow. And this pond behind me is a great example. We have a settlement area, and you can see this point, actually. There's a rock point built up to actually change the input flow direction. And there's a little area inside the pond where the sediment can settle out, all right? And that changes the velocity of the inflowing river to allow that settlement out as it changes the corner and collects in that smaller area. And we want all that sediment that's being washed into this collection pond to not flow down further into the natural environment. So we use that concept, but the concept actually comes from nature. In the marine environment, we get barrier bars built up. You can see these wonderfully in satellite imagery, and you'll get a lagoon or an estuary forming in behind this barrier where there's calm water. Now, those barriers could also be coral reefs, for example. They may be submerged under the water, but they're still breaking the wave action and creating a calmer environment in behind these barrier reefs. And that allows the organisms to really thrive and grow and build up the coral reef environment. The key thing is the change in velocity of the transport media. That could be the water, of course, from a river or the wave action, but also wind. Wind is a tremendous mover of fine sediment. And I actually have a great example from the beach in Coburg. They constructed a snow fence anticipating in the spring and over the course of the winter when there's no snow on the beach, there's a lot of wind, and that's going to move a lot of sediment. So wind's predominantly coming off the lake here. There's Lake Ontario. Wind's blowing up. Velocity's dropping because of all the little slats in the fence. Drops the wind velocity as it passes through. When the wind velocity drops, that means the grain size it can carry also drops. So only finer sand can get blown on and the coarser fragments drop out behind. And you can see they've got all these fences all along to reduce the amount of sand that's blown away from the beach. And it builds up actually a dune. A natural dune does the same thing. A natural dune is a hill, and as the wind goes up that hill, the velocity slightly decreases. We drop out some of the coarse sediment in the wind, and it gets rolled up over the end. And at the steep side, we'll deposit more sediment, and they kind of migrate with time. The same thing actually happens under the water. So as the waves crash onto the shore, we have wave orbitals underneath the water, moving sediment. You can see beach bars under the water. You've walked around the beach, you've maybe experienced walking out, the water gets deeper, and then it gets shallower again. And those are bars submerged under the water, made of sand likely, and they are migrating towards the shore because of the wave action. Now, when the waves crash onto the shore, they're also creating a longshore drift current, and that can actually move a tremendous amount of sediment at the shoreline. This is seen very easily in satellite imagery. You can see suspended sediment in this image where the water is actually passing around a point of land. Just like this point bar behind me that's constructed, the velocity of the water changes as it passes around this point, and we either pick up sediment off the end of the point and we'll deposit it behind the point. It all depends on the current. Sediment deposition, when we decrease the velocity, or erosion when the velocity increases. And that erosion we need to try to understand in our coastal environments because it can have a detrimental effect on our coastal communities. We can take an example from a beach in Midland, Ontario, and you can see these dunes. They have vegetation growing on them. And that vegetation is holding the sand in place. But if the vegetation gets damaged from us walking on it or other factors that affect the growth of that vegetation, then that dune is going to start to migrate. We also construct, just like in the settlement pond, but at a coastal environment, we construct many barriers to protect our coastline. And you can see that even in a small video here of the shore at a lake where I grew up, a small berm constructed of larger rock fragments in the water, and they are actually protecting the shoreline slightly, although the water is quite high there, but they're reducing the wave impact and that energy in that environment that really moves a lot of sediment. And that's the engineering link. We need to understand this coastal environment so that we can preserve what we have already today and protect our infrastructure that is at the shoreline. Thanks for watching.